Hi, my name is Marisa. Can you please assist me with this question?
Okay, this question is great if you're just trying to grasp the idea of ratio and proportion. We're not going to be working with numbers, there are no measurements, it's just dealing with ratios. So it's a really great question. Let's take a look. It says, in the diagram, ABC is a triangle with DE parallel to BC. So DE is parallel to BC. Immediately, that should tell you that this whole triangle is divided in proportion by this parallel line. Secondly, GF is parallel to AB. So we have GF parallel to another side of the triangle. And lastly, it is given to us that AG, this side here, is equal to EC, which is this bit here. So we know that these two lengths are equal. Firstly, it says complete the following. Okay, so we have some ratios that we need to deal with. AC over GC. We have AC over here and GC over here is equal to something over FC. So let's identify FC. FC is this short thing here. So we had long side, or the complete side of the triangle, over a chopped off side by the parallel line. So now we need to correspond with this triangle. So we've got long side, shorter side, and then on this length, BC, we've got the shorter side. So the long side that corresponds is BC. So we're going to have BC over FC. Okay. Second ratio, EC over AE. Okay. EC over AE. So let's get rid of this. EC over AE. EC is here and AE is here. Okay, so we have little short side over another shorter side is equal to DB over what? Okay, so where's DB? DB is over here. So easy, the corresponding arc would be AD. Okay. So this gap over here is AD. It's DB over AD. Easy stuff. Remember the reason for these two statements? Line parallel to one side of the triangle. Okay. Next, it says prove that DF is parallel to AC. DF, which would be this line to connect here, DF is parallel to AC, which is this side here. Okay. So how do we prove that lines are parallel? So remember, if you're given a triangle and you have a line that's drawn parallel to one side of the triangle, you know that it immediately divides the sides in proportion. But now if you're trying to prove that a line is parallel to one side of the triangle, you need to show that the lines are in proportion, that the sides are in proportion where they get cut by that parallel line. So we need to go backwards. So we need to prove some proportion. Let's take a look at this. So to prove that DF is parallel to AC, we need to prove that DF cuts these other two sides proportionally. So we need to prove that BD over DA is equal to BF over FC. Okay, so how do we even start with this? Well, we know, remember, these two lengths are equal here. Okay, so if we look firstly at the triangle, let's say we have this triangle here, ACB, which is the big triangle that we have, and we're looking specifically with the parallel line GF. So we have G there and F there, and we know that these lines are parallel. Okay. We know that BF over FC is equal to, on the other side, AG over GC. AG over GC. Why? Because line drawn parallel to one side of the triangle. Okay, so we have one statement, BF over FC is equal to AG over GC. Okay, so we've dealt with the one ratio that we're trying to prove, BF over FC. We've got an expression for. Now we need to find a ratio for BD over DA. Okay, so now if we look at the triangle as it is orientated that we have it now, we've got A, B, C, and we're going to look at this line here, parallel to the base, okay? So we've got DE here, DE, and we know it's parallel. So if we look at the ratios, we have BD over DA is equal to EC over AE. Okay, so BD over DA is equal to EC over EA. Let me just double check that. EC over EA. Okay, so we are trying to prove that these two ratios are equal to each other. How do we do that? Let's look at what we were given. Remember, we were given that AG is equal to EC. So here we have AG and here we have EC. So, but AG is equal to EC given. Also, GC and EA, how do we find that those two are equal? GC and EA. Okay, so if we find an expression for these two lengths, let me use a different color and let me get rid of this stuff over here. If we look at GC, GC equals GE plus EC. GE plus EC to give us that whole length there. And if we look at EA, EA is equal to GE plus AG. Now remember, these two expressions are equal to each other. So GE plus EC and GE plus an expression that's equal to EC means that these two sides are equal. GC is equal to EA. Okay, so obviously you would write that as part of your proof. You would bring that down here. Okay, and then you can carry on and say, therefore, whichever one you want to rewrite, I'm going to write the second one. BD over DA is equal to AG over GC. And therefore, BD over DA is equal to BF over FC. So basically, what we've proven here is that this ratio of these two sides, BF to FC, is equal to BD to DA, which means that these two lines must be parallel to each other. Okay, so that was what you would conclude after this argument. You'd say, therefore, DF is parallel to AC because the sides are in proportion. Okay, easy peasy stuff. Lastly, it says if 3AG, got AG and EC equal to each other, is equal to GE. Okay, so if we have one AG here and one AG there because these two sides are equal to each other, it means that GE has 3 in it, okay? So 3 of these lengths of AG can fit into this length GE. Show that the area of triangle DBF, which is this little triangle over here, DBF, over the area of the big triangle ABC is equal to 1 over 16. Now, oftentimes, when they say, prove that this line is parallel to this line, if they follow on with another question, it means that they're going to ask you to use what you've just proved. Bear that in mind. So look and see. We've proved these two lines are parallel. How do they help us in this next question? Let's take a look. We've proved that these lines here are parallel to each other. So that means that obviously we need to find an expression that will relate these two areas together. So let's take a look. Area of triangle BDF is equal to, well, we have that length there and that length there. Remember, your area of a triangle is equal to half one side multiplied by the other side multiplied by the sine of the angle included between them. So we're going to have half BD multiplied by BF multiplied by sine of angle B. Okay, so that's the area of this tiny little triangle over here. Now, if we look over here, we've got area triangle ABC, which is the big triangle that we're trying to relate. It's going to give us a half of the whole side, AB, multiplied by the whole side, BC, multiplied by sine of the included angle, which is still angle B. Okay, so now if we put these two areas over each other, let's write that out. 1/2 BD multiplied by BF multiplied by sine of B over 1/2 AB multiplied by BC multiplied by sine of B. Immediately we can see that the halves are going to divide into each other to give us 1, and so are the sine of angle B. So we're going to get BD multiplied by BF over AB multiplied by BC. Okay. Now, from the previous question, we found, remember, that this ratio is equal to this ratio, which means that it's consistent throughout the whole triangle, because remember, we've got a whole bunch of ratios that are equal to each other. Okay, and here, AG over GC is going to equal 1 AG to 3 AGs plus another AG is 4 AGs. Okay, so this ratio here is 1 to 4. If I drew out my little ratio bubble correctly, we would have a ratio here of 1 to 4, which means that these ratios are consistent because we've proved through all of these parallel lines that the ratios are equal to each other. So AG over GC is 1 to 4, okay? And that means that these ratios are going to be 1 to 4. So we're going to have 1 to 4 as one ratio, multiplied by another ratio of 1 to 4, which gives us 1 over 16. Okay, so basically it's saying that this area of this triangle is 16 times smaller than the area of the big triangle, or they'll take 16 of these little triangles to fit into the big triangle.